In this video, we're going to talk about reasoning in algebra and geometry. So this is from section 2.5 in the book. And so let's start with remembering some of our properties of equality. All right, so first we have the addition property of equality. So remember, this is just if you have something where, if you have an equation, if you have a situation where one side equals the other, right, which is what happens in an equation, then you can add the same thing on both sides and still maintain the integrity of that equation, right? The relationship between one side and the other. Okay, so as long as you add the same thing to both sides, then the relationship remains true. The same thing with subtraction, right? We have the subtraction property of addition, so we can subtract the same thing from both sides and maintain equality. And then of course we have the multiplication property. We can multiply the same thing on both sides of an equation. And with the division property, as long as we're not dividing by zero, right? As long as this value is not zero, we can divide the same value on both sides of the equation and maintain the equality. So, and these are things that we often use when we're solving equations, right? When we're trying to isolate a variable, a lot of times we add, subtract, multiply, or divide to both sides to get that variable isolated, right? All right, so now next we have the reflexive property, which seems kind of obvious. It just says A equals A. This will come in handy though, and we'll actually use the reflexive property of congruence a lot, and even in the reflexive property of equality. All right, then the symmetric property, if A equals B, then B equals A, right? So if we have an equation, it's symmetrical, right? We can flip it around and it still holds. All right, so the transitive property, this is similar to we likened it to the law of syllogism that we talked about in the last video. So if A equals B and B equals C, right? If you have a same value equal to two different values, then those two different values must also be equal, right? So if A equals B and B equals C, then A must equal C, right? Okay. So if A and C are equal to the same thing, they must be equal to each other. And then the substitution property, basically, if A equals B, then B can replace A in any expression, right? B and A are interchangeable, right? It's the same thing if you have, if I have a $10 bill and you have two fives, right? We can buy the same item or items with either value, right? Because they're equal value. All right. So a couple other important properties. The distributive property will come into play. Remember that if we have a value multiplied by a sum or difference, the quantity of a sum or difference, then we can just multiply the quantity outside by each of the values inside, right? And then get the sum of the products, right? Or the difference of the products, depending on, what operation is happening inside the parentheses. All right, so we know the distributive property. So here we have properties of congruence, which you'll notice are similar to some of the properties we've talked about. So we have the reflexive property, which basically says segment AB is congruent to segment AB, right? Angle A is congruent to angle A, right? So a lot of times that happens when two figures share a side or an angle or things like that. That's when you use the reflexive property, and it's actually going to be something, once again, that we'll see a lot, even though it seems obvious. So remember that one. Symmetric property of congruence. If segment AB is congruent to segment CD, then it works the other way around as well. Then segment CD is congruent to segment AB. Same with angles here, right? Angle A is congruent to angle B, then angle B is congruent to angle A. All right, and then lastly, the transitive property of congruence, similar to the transitive property of equality, right? If two things if two things equal the same thing, then they must be equal to each other, right? If segment AB and segment EF are congruent to CD, then they must be congruent to each other. Okay, same thing with angles. All right, so let's use this or use those properties in some of these examples. So we're given a statement here, and we're asked to justify each statement with a property from algebra or a definition or postulate from geometry. So in some of these we'll have multiple things. Like here, this is the reflexive property of equality, BC equals BC. It's not congruence because we're not using the congruent symbol there. So we're talking about lengths BC, right? Not segments or lines or so forth. So we're given an initial statement, AB is equal to CD, and so this BC equals BC, that's by the reflexive property of addition, right? And so then here we're just adding BC to both sides, right? So we start with this initial equation, we're just adding BC to both sides, and so that's the addition property of equality, right? All right. Okay, so number 2. So here we have, it says we have an equation, 2 times the measure of angle 1 is equal to 72. And then finally we end up with measure of angle 1 is equal to 36. So what happened from point A to point B? And you may have guessed it, what we did is we divided by 2 on both sides, right? And so that's the division property of equality, right? All right, number 3. If the measure of angle A is 1/2 times the measure of, or 1/2 the measure of angle X, and 1/2 the measure of angle X is equal to the measure of angle B, then the measure of angle A must equal the measure of angle B, right? So basically we have two things, measure of angle A and measure of angle B, that are equal to the same thing, 1/2 measure of angle X. Therefore, they must be equal to each other, right? So that's right, the transitive property of equality. Number 4, if point B is in the interior of angle XOY, then the measure of angle XOB plus the measure of angle BOY is equal to the measure of angle XOY. So do you remember that one? That one, we didn't talk about it in this video yet, but that one is the angle addition postulate, right? So in case you forgot, right, basically we're saying that point B is in the interior of angle XOY, right? So basically we're just saying that the two parts equal the whole, right? So angle addition postulate. All right, and then lastly we have number 5, if 2 plus yz equals 8, then yz equals 6. So how do we get from point A to point B? That's right, subtracted 2 from both sides. And so, excuse me.